Hello students, in this video we will find least common denominators. As an illustration, let's find the least common denominator for the fractions 7/10 and 1/25. One way to do this is to write each of those denominators in prime factored form. 10 in prime factored form is 2 times 5, and 25 is 5 times 5, or 5 squared. Now your LCD contains every factor in both lists, so it contains the factor 2 along with the factor 5, along with the greatest exponent that you see, and we see the greatest exponent 2 attached to that 5. So our LCD is 2 times 5 squared. In other words, that's 2 times 25, or 50. Now, another way to find a least common denominator for numbers is just create lists of multiples. For example, the multiples of the number 10 are 10, 20, 30, 40, 50, and so on. And the multiples of 25 are 25 times 1 is 25, 25 times 2 is 50, and then 75, and so on. And then notice that the least common multiple is the number 50, which is what we obtained earlier. As we look at part B, let's write 8m to the 4th, okay? 8 is 2 times 2 times 2, or 2 cubed, times m to the 4th in its prime factored form. 12m to the 6th, okay, 12 is 4 times 3, and 4 is 2 times 2. So let's write 12 as 2 squared times 3. And don't forget that m to the 6th. Now our LCD contains every factor that we see. We see a factor 2, we see the factor 3, and we see the factor m. So now we include the greatest exponents attached to either factorization. So we'll include the 3 as our exponent of 2. We see just a 3 to the 1st power and m to the 6th. Now multiplying. 2 cubed is 8, times 3 is 24, m to the 6th is our LCD. So just summarizing with steps for finding the LCD. Step 1, factor each denominator into prime factors. Step 2, list each different denominator factor the greatest number of times it appears in any of the denominators. Step 3, multiply the denominator factors from step 2 to obtain the LCD. And what we're doing here is we're preparing for adding and subtracting fractions, because when we add and subtract fractions, we need to determine a lowest common denominator. So this is prep work for that. Now in example 1, we want to find the LCD for the fractions in each list. Well, our first fraction, let's factor it. Factor out the greatest common factor, x, and let's write that x times x minus 4. Our second fraction is a difference of squares, and it factors x plus 4 times x minus 4. Now our LCD contains every factor that we see. We see a factor x, we see a factor x minus 4, and we see the factor x plus 4. And we include these the greatest number of times they occur in either of the denominators, and these factors only occur one time in each. So our LCD, x times x minus 4 times x plus 4. Now part B is unique. Notice that those denominators are opposites, x minus 1 and 1 minus x. Now, we can choose as our LCD either of those denominators. So choose either x minus 1 or 1 minus x. Now my preference would be x minus 1 because that's written in decreasing degree order. Degree 1, then degree 0. But you could choose either of those because they're opposites. Part C, let's begin by factoring. Let's see, this first denominator factors z plus 6, z minus 2. Our second denominator, that's going to factor z plus 6 times z minus 5. So that's our first and that's our second. And then that third denominator is a perfect square trinomial. It factors z minus 5 times z minus 5, but let's write that as z minus 5 quantity squared. Now our LCD contains every factor that we see. We see z plus 6. We see z minus 2. We see that z plus 6 again, but we've already got it. You don't have to repeat it. Now we also see z minus 5. And we want to include the greatest exponent that we see, so our LCD will contain z minus 5 squared. So every factor that you see along with the greatest exponent attached to that factor. And our last example for this section, we're going to practice writing equivalent fractions. So here we're going to write each rational expression as an equivalent expression with the indicated denominator. 3/4 is equal to what number over 36? So what you want to be thinking about here is our fundamental property of rational expressions, or you might say the identity property of 1, or multiplication identity property. In other words, we're going to multiply 3/4 by 1, in this case in the form of 9 over 9. Because 4 times 9 gives the 36 that we see above. Multiply the numerator by 9 also to obtain 27. 3/4 is equal to 27 over 36. And we're building these fractions up. In part B, we see 7k over 5 is equal to something over 30k. So let's just step down here below and write 7k over 5 and think, what is 5 multiplied by to obtain 30k? Well, that would be 6k. Do the same thing to the numerator because we're multiplying by 1, aren't we? Okay, this fraction in red has a value 1. So we're not changing the value of our fraction, we're simply building it up and changing the way that it looks. Multiplying, we obtain 42k squared over 30k. Therefore, our numerator above must be 42k squared. Part C, 2a plus 5 is multiplied by 3. To obtain 6a plus 15, so do the same to the numerator. Equivalent fraction is 27 over, as you distribute, you see your 6a and plus 15. So the blank above must be the number 27. Lastly, part D. Let's write our initial fraction, 5k plus 1 over k times k plus 2. I just factored out the greatest common factor, k. This is going to allow us to compare things a little easier. We see there's an additional factor, k minus 1. The denominator has been multiplied by k minus 1, therefore we will do the same with the numerator. Multiplying by 1 here, aren't we? That's going to give the required denominator k times k plus 2 times k minus 1. And the numerator, just going to write this in a factored form here, 5k plus 1 times k minus 1, and that is the numerator that we need to see above. So in summary, in this video, we have created equivalent fractions by multiplying by 1, and we have determined least common denominators. Good luck with those.